Problem 14, Chapter 4. Assign relative priorities to each of these groups. Okay, for A, first thing we need to do is look at the atomic number. The atomic number of carbon is 6 and hydrogen is 1. So automatically, hydrogen is going to be the fourth priority. So now that we have a three-way tie here, we need to look at the next carbon, or excuse me, the next atom over. So we have oxygen, which has an atomic number of 8. Methyl has only hydrogens, so he's going to be the second to last in line. And then this carbon has a 6. So this group will have top priority, followed by this group, 3 and 4. So for B, we have oxygen has top priority here. And now we're going to look at our carbon groups. We have a carbon attached to a bromine, we have a methyl, and we have carbon attached to an oxygen. So the bromine is going to take the higher priority here, followed by the oxygen, then the methyl. For C, we have 3 carbon groups and a chlorine. Chlorine is going to take top priority, and we're going to have to rank our carbon groups. But it looks like we're going to have to go 3 atoms over. Now, because this group is a carbon that is attached to 1 hydrogen and 2 methyls, this is going to have the next priority, because this carbon is attached to 2 hydrogens and 1 carbon. This is also attached to 2 hydrogens and 1 carbon. So then we move over again and we get to bromine. So this has the third priority and this has the last priority. For D, we have to look at this double bond as 2 bonds to carbon. So like it's attached to 2 carbons. This is a special instance as well. It forms 3 bonds to carbon, so it's considered to be attaching to 3 carbons. And because that is the top priority in this set of 4, this is our number 1, and this is our number 2. Now we got to look at these two for 3 and 4 because we have 2 carbons bonded together. That'll be number 3, with methyl as number 4. Problem 16. What's the configuration of each of these compounds? You have to remember the Fisher projection rules when assigning your R and S configuration. So first let's prioritize. For A, this methyl group is going to be number 4. This group will be number 1. In between these two, we have a number 2 and a number 3. So my priority is going counterclockwise, but my lowest priority is vertical. So that means this is an S configuration. For B, first let's assign priority. Hydrogen is going to be number 4. Oxygen is going to be number 1. This is going to be number 2 and number 3. So we're going counterclockwise with my lowest priority being in the horizontal. So this is an R. For C, this is number 4, here's number 1, here's number 2, and number 3. So we're going clockwise with my lowest priority in the horizontal, therefore this is the S configuration. For D, methyl is number 4, my heaviest group up here, that's 1, here's 2, here's 3. So again, we're going clockwise, lowest priority in the horizontal, this is the S configuration. Problem 17. Now your book suggests that the easiest way to figure out if these are identical compounds or enantiomers is to decipher whether they are the R or S configuration. I personally think it's much easier to see if you have a molecular model kit. So if you have a kit, this would be a great problem to pull it out for. But to assign the R and S designation to see if we have the same molecule, we would first assign priorities. Now here, where I really need the molecular model kit because I have a very difficult time visualizing this. In fact, this is the third time I've recorded this problem because I've screwed it up twice already. So if you hold number 4 to the rear, so what you see is priorities 1, 2, and 3, then they turn in a clockwise fashion, which makes this an R. Now again, assigning the priorities, 1, 2, 3, 4, hold number 4 to the rear, you still see that this is an R configuration. Therefore, these are identical. For B, again, assign the priorities. Mentally put 4 to the back or get your molecular model kit and hold 4 so that you see 1, 2, and 3 and see which way they turn. This one turns counterclockwise, so this is the S and this is the R. So this is a pair of enantiomers. When you go through the same process for these are also enantiomers. Now remember the rule for Fisher projections here. That can get confusing for a lot of people. We assign our priorities. And for this particular molecule, the lowest priority is in the vertical, and we are turning clockwise. Therefore, this is an R. For this projection, the lowest priority is in the horizontal, and we're turning clockwise, so this is an S. So these are enantiomers as well. Problem 18. Draw a perspective formula for each of the following. This might be another good example for a good problem to use your molecular model kit if you have one. First, let's write out the structural formula just to make sure that we know where our asymmetric center is. We know we have 4 carbons, and we know on the second carbon we have a chlorine group. So here's a terminal carbon, so he gets 3 hydrogens. We got an interior carbon with 2 hydrogens, and this one has 1. So here is my asymmetric center, and this is the one we're going to build off of. Now, because hydrogen has the lowest priority, I'm going to set him to the back immediately. And I'm going to put chlorine in the number 1 position because that's easier for me to see. That means on the wedged position and the other in plane position, that's where I'm going to put my ethyl and methyl. Now is where you have to look towards the conformation. This is an S conformation. Therefore, we need to turn counterclockwise. So I'm going to end up putting ethyl here and methyl here. And that is the perspective formula for A. Now for B, again, let's draw out the structural formula. 1,2-dibromobutane. We know we have 4 carbons. And we know we have a bromine here and a bromine here. And then I will fill in my hydrogens. So my asymmetric center is this carbon here. And again, I'm going to put hydrogen to the back. Bromine's going to get number 1. And then I have my in plane and my wedged position. Now, because this is an R conformation, I know I need to turn this way and put my number 2 priority on the wedge. And in this case, my number 2 priority is going to be this side, and my number 3 priority is going to be the ethyl. Like that.